in this video we're going to talk through objective 3, find the vertex of a quadratic function from vertex form. So, to begin, I'm going to go through an example problem, and I'm going to have you pause the video and try a similar problem on your own. But before we do that, I have to talk about what vertex form is. It should be a review of Algebra 1. But vertex form is given to you as y equals a times the quantity of x minus h squared plus k. In this case, we need to know what a is, what it's doing to the function, what h is, and what k is. So a is the leading coefficient, same as in standard form, but in this case, I'm going to call it a multiplier. And I'm going to reference that later in a different objective. It's a multiplier because based off of the parent function x squared, if a isn't 1, then it changes the way the parabola looks, the shape of the graph. So it either is going to make it skinnier or wider. All right, the h term in this function of h is going to be the x value, so a very important piece of vertex form. It's the x value of the vertex. And then the k term is going to be the y value of the vertex. The vertex. Now, another very important piece of information is what has to do with the h value, all right? Before I get into that, another way I think of this, let's use this color. Here's the power of 2. Quadratic power. To the left of that is the h value. And if I write the vertex, the left value that comes first is the x value. So h coincides with x because they're both the left value. And then to the right of that power is the k value. And that coincides with the y because the y is the second or the rightmost value for the vertex. So they go hand in hand. H goes with x, k goes with y. Right? Just make a mental note of that. The other thing I have to mention before I actually do an example is that the h term is lying to you. Meaning, it's opposite whatever it is in the function. I like to sing the song to help me remember. To the left, everything you own in a box to the left. So to the left of this power, that's a Beyonce song, and apparently Jay-Z lied to her about some things. So to the left of the power, everything you own in the box to the left, is lying to you. So that term is always opposite of whatever it is in that function when you actually write out vertex. So you can use that song to help you remember. I actually have done that, and it's helped me. I'm going to put this into practice then. The I do example, it's given to me in vertex form. Y equals 2 times the quantity of x minus 1 squared minus 5. Now the biggest clue that helps me know that this is in vertex form and not standard form, honestly, is the quantity, x minus or plus a number. That won't always be there, but if I know for sure that if it is there, that it's typically going to be in vertex form for our purposes. So if there's ever a quantity or parentheses there, you can know it's vertex form. Now, before I begin finding the vertex, I'm actually going to identify those key players, the a, the h, and the k. Now, the a, in this case, is 2. That's the multiplier, meaning this function is going to be skinnier than the parent function. The h is positive 1, because remember, the h, or to the left of the power, is lying to you. In this case, it's x minus 1. So that makes the h value opposite of whatever that is, so it becomes positive 1. And then the k is negative 5. The k is straightforward with you, it's telling the truth, and that's to the right of it. So this is the k, to the left of it is the h. And so the k value always tells the truth, so in this case it's minus 5 in the function, which becomes negative 5 for the value itself. Now the vertex is just made up of the h and k value. So the h goes first, and the k becomes 1 comma negative 5. And again, trickiest part of this process is whatever the function is, in this case it's x minus 1, whatever the h value is, it's lying to you, so it's opposite. In this case it's positive. If it was x plus 1 in the function, it'd be a negative 1 in the vertex. So I have found my vertex, all right? So I know that to be 1 comma negative 5. Now we can go ahead and fill in a few other things in this box. We're not going to do the y-intercept right now or the x-intercepts. I want to be able to find those after we learn how to draw these in a later objective. So we're just going to fill in whether or not the parabola will open up or down. And if you remember, that has to do with the a term. In this case, the a term is positive 2. So the key word there is positive, whatever, if it's positive or negative. In this case, it's positive. It doesn't matter what the number is, it's just that it's positive. That tells me it'll open up, or it's smiley or happy. And then the parabola, if it's positive and it opens up, it'll have a minimum. All right? And then finally, the other piece of information I care about is the axis of symmetry. Just to get practice with it, you need to know that the axis of symmetry is always the x value of the vertex. So x equals 1 is the axis of symmetry for this case. All right, so that's pretty straightforward. That's why vertex form is so useful. It gives you some key information right away. So that's how I would do this process. At this time, I'd ask if you please pause the video so you can try an example on your own and check your work with mine. All right, at this point, you should have paused the video and tried this example on your own. And here is the work that you should compare your work to. Hopefully it matches. I found the vertex to be negative 2 comma 3. Remember that h term, or the x value, is lying to you, so it's positive 2 in the function. So in the vertex, it has to be negative 2. And then, because the a term is negative over here, that has to do with whether it opens up or down. So the function itself is negative in its whole, so it opens up down, which means that it has a maximum for the parabola. The parabola will have a maximum. And then finally, the axis of symmetry is the x value of the vertex, which is negative 2. Now, before we finish this video, I want to show you two different examples. So please write these down at the bottom of your page. Two unique situations that can occur. Okay? And then, I'll do it over here. All right. Two situations where either the x value or the y value will be 0 in your vertex. So if I was going to identify the vertex of this function on the left, 3x squared minus 4, I can still consider this to be vertex form, even though there's no quantity. The special situation that occurs here, though, if I identify the power of 2 to the left of that, there is no value that has a quantity with x. Remember this, the leading coefficient is the a term. So in this case, the a value is 3. But again, that has nothing to do with my vertex. So the h value in this case, because there's no quantity, there's nothing paired with the x in parentheses, it's 0 because it doesn't exist. So that's one of the special situations. If you see something where there's no quantity, you assume the h value is 0, and then the k value is to the right. So this is the h. To the right is the k value is negative 4. Next, in this example, is 0, negative 4. Now, the other special case you'll see is when the k value doesn't exist. Okay, and the first one, the h value, this one, the k value. So again, this negative 4 is the a value. It's nothing to do with the vertex. All right? But I identify the power of 2 to the left. Now there is a quantity paired with, or there is a quantity with the x. So there's a number that's being added or subtracted from x in parentheses. So that tells me that there is an h value. A value is negative 4. So that tells me there is an h value. Okay? There is a number to the left of the power. In this case, it's negative 3 because the h value is always lying to you. But if you notice, there is no k value. So in this case, then, the k is 0. It doesn't exist. So the vertex is negative 3, 0. So those are the two special cases that you'll run into as well in this. And that concludes this objective of finding the vertex of given vertex form. Thank you for watching.